So we can continue the project session 2. So last session, we have finished this training room. Okay. Still like a thermal insulation, acoustic insulation, labeling, and thermostat has to be provided. And now we can move to this one. Which one? Discussion rooms. Actually, this is our discussion room 1. Okay. Discussion room 2 and discussion room 3. For training room 1, we did heating and cooling load calculation using HAP only. So when you are doing it, discussion rooms, you should do by HAP only, heat load. One machine I can place somewhere in the discussion room here or here. I'll be placing the machine here. And I'll be taking the duct. Then I'll be providing to each spaces. But by the help of a single machine, if you are introducing air to the multiple spaces, in the duct branch, we should provide VAV, variable air volume. Okay. Let me do that. So I'm selecting the machine. I don't want this much bigger machine since the capacity is limited. I'm slightly making smaller. Okay. So just copy this one. I don't know actual dimension. Actual dimension we should take from the technical data sheet after the selection. At present, we are not having that. So I'm selecting this one, like scale it, SC enter. With respect to the base point, I'll be scaling that into 0.75 because I don't want bigger because this is like a 3.8 ton. This is 1.8 ton machine only. So definitely the sizes will be limited. And I'll be rotating this one. Okay. And make sure that this has an HVAC FCU layer. Okay, fine. Just select it. Copy with respect to this point. I'll be placing in discussion room 1 somewhere here. Okay. Select HVAC SAD layer. And I'll be making a line also from here. It's a center point. Okay. Minimum distance, now it is on the wall only. Minimum distance from the wall, we should keep 300 mm. M enter, move it. From there, I need minimum 300. Okay. When I placed it. So if you want to move it like slightly left side or right side, you can do that. But otherwise, you can keep it like this, no problem. Anyhow, how I am going to do, I don't know, let me do that now. For time being, I'll be doing like this. I'm just making the route now. I'll be sizing it later. And that is for my first one. Okay. Then for my second one. And the third one. From here. Okay, this line, let me finish it. TR double ender. Here. Okay. Finish this one. This is my route. And in these branches, I should propose VAV. Okay. Fine. Let me mark the flow rate first. So why I have taken this back side like that only we can take. When you are making the 2D, you will get the idea. Okay. See, this is a route that I am proposing. If you're having any other route in your mind, you can. No problem. Routing, there is no special theory to how to route it and all. When you are routing it, your length should be minimum. Whenever it is practically possible to avoid the backflow, you have to do it. Number of fittings should be minimum. Pressure drop should be minimum accordingly. Okay. Anyhow, overall, we are getting 350 liter per second. 350 liter per second. What's the starting branch length? The first 3 meter, I should provide the from here to here. Now it is okay. For this machine, until here you can provide the is exactly 3 meter only. But for this case, wherever the 3 meter line is coming up to that extent, you should provide the acoustic insulation. You should consider it. Select it. Okay. 3 meter line I am making. You can say if you are providing acoustic insulation up to this side, means not only in the starting duct, in second duct also we should consider the acoustic lining here also. Exactly this also, here also we should consider, because from the starting, suppose if this is 2 meter, here we should provide 1 meter. So 2 plus 3, 2 plus 1, 3 meter from the starting to 3 meter. So that's why from the starting point to here, since it is 3 meter, up to this point we should provide. So acoustic insulation allowance has to be considered for not only in the starting duct, here also we should consider. Okay, so 350 liter per second. 350 liter per second, 350. Keep it there, that point. This is acoustic insulation line. Okay. Okay. I'm changing that into metric. 350, let's say 0.8 Pascal per meter. Try to maintain the velocity same as before, 6 meter per second. See, suppose 350, 250, 300, 300. You can try for 300, 300, 300, 275 I'm getting. 300, 275 I'll be rounding into 300, 250 or 300, 300. 300, 300 will be good. Okay, so starting back to 0.6 Pascal per meter, 4.1 meter per second. Fine, 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 no problem. 300. So I'll be getting my ducted dimension 350, 350. Why? Including acoustic insulation, but actually I need 300, 300 only. Okay, velocity is less than that only, so leave it. Okay. That is my starting duct. Okay. Let me make it first. And after that, we can size this one. SAD 350, 350. So offset 350 means 175. 175 here, 175 here. And after that, from the mouth, I should make a shift at approximate distance of 800. Angle 270 plus 45, 315. Okay. Now this one you can mirror or you can draw from that side as well. Shift at approximate distance, let's say 850, angle 225. Now the unnecessary lines you can trim. Create a line or polyline, then you can join it. Okay. I don't want these two lines, so I'm deleting it. Unnecessary lines that we are having inside, you can trim now. Okay. Now here I have to provide VAV, because individual, by the help of a single machine, if you need individual control in different spaces, definitely the branches we should propose VAV. Straight it is not possible, because if you want to connect the VAV, we need a minimum gap there, like a 750 to 900 we need. We have to place it, then only we'll be getting the idea. VAV. So VAV, you can do one thing, available VAV block if you are having, you can select it. Otherwise, we have to go to the technical data sheet of a VAV. From there, VAV block we have to make for drawings. But when you are working in a company, definitely you can have a discussion with the VAV supplier. They will provide the block. But for time being, I'll be making it. VAV, we will be selecting with respect to the CFM only. So an available catalog, I will be selecting now. VAV catalog. Okay. The VAV data sheet I am selecting now. And I'll be going to the model. You can come down. This is a model. Different model number of VAV. Okay. Here you can see 45 to 230 CFM, the first model, VAV PID 100. Actually, for this model, Cosmos, this dimension is representing the inlet. Normally, the inlet of VAV is 90% diameter only will come, damp, to adjust the flow rate and all. For example, inlet is diameter, but outlet will come rectangle, no, or square in shape. But if the CFM range is increasing, instead of diameter, for example, 600, like 1420 to 7100 CFM ranges, inlet diameter is coming like inlet, it is not diameter, no dimension, it is rectangle in shape only. So it may vary, but rest everything you can check, the inlet is diameter only, round in shape. Okay. VAV dimension they are providing here. For example, this is a VAV. Okay. And this is a top view. Which one is the top view? This is a top view. When you are looking from the top side, here you can see this is a top view. When you are looking from the top side, this is your inlet diameter. Here you can see inlet, airflow that is entering inside. Okay. And this is a width of VAV, this one. And this is a length of VAV. Length. So how much length can come? For example, PID 100, the length is 400. Means from this point to this point, that will come 400 mm. Here you can see the collar, how much it is extending beyond this direction. 4 inch, normally 4 inch, near to 4 inch it can come. 100 mm or near to 100 mm. This A is this projection, collar, how much it is projecting. Model this one, the A is projecting how much? 95, somewhat near to 4 inches, right? 95. Inlet diameter is 100 mm because this is inlet diameter. So diameter of this one, this is front view only, face view. Front. Inlet diameter is how much? 100 mm. And we are having a box, no? Like electronics, electrical connections, we are having a box. Box dimension, they have not provided anywhere. So approximately we can make it. So I'm just going to make this one, the block, as per this dimension, because my range is 227 CFM. 227, the first model I should make. Length is 400, width is how much? Width I should take, width is 250. This is a width. From here you can see this is length only, this distance. Which one? Outer width, this one. This one, from the face you can check this Y, you can take that one. Y or even W also we can. No. VCD is just a damper, right? VCD is just a damper. That VCD is an accessory. VCD is not an equipment. Correct. Volume control damper is just we are using for balancing. It is only for balancing, means to adjust the airflow rate within the duct. Valve, how we are using the valve, that's why we are using it. But VAV is an equipment. By the help of a single, for example, 3 rooms, it is delivering the airflow, right? Discussion room 1, discussion room 2. In the HAP classes, we have studied it. HAP session. Discussion room 1, discussion room 2 and 3. For example, a single machine is delivering, right? For example, discussion room 2 and discussion room 3, if there is no people, then how we can adjust the airflow rate? Correct. So the branch that is going there will be proposing a VAV there. VAV, we might be using a bypass type of VAV, or we might be using a pressure independent type VAV. What VAV it is? This is PID VAV only, pressure independent type. Correct. Yeah, that's why. So whenever the different spaces are working with the different working time and temperature settings, so we have to go for VAV. VAV is an equipment. So from the VAV, we will be having a thermostat. Accordingly, only we'll be adjusting it. So if the flow rate is not required, the VAV damper actuator will close the airflow rate. Whenever you required it, you can open it. Accordingly, whenever with respect to the temperature changes, the rate of flow of airflow through the duct branches, it will vary as well. Okay. Anyhow, length is 400, width is how much? 250. No, 250, not that one. Length, this direction I need. This one. This one, from here I can take. How much it is? Y only. Y. Some more approximately Y, but that is okay. Y. How much it is? Y is coming 300. So 400, 300. Let me make a block there. 400 means width is 300. Other dimension is 400. Correct. So this is 400, 300. And what about this distance? From there, we need a projection of this one, A. Top view, no? A how much it is? 95. So you have to make it O enter, that is 95. Now D, diameter. Correct. There we are having this one. Top view, no? This one, what is that? This inlet only, diameter 100 mm. So 100 mm means O enter. 100 mm means 50. 50 here, 50 there. Now you can TR double enter and trim these things. Okay. Now in the top side, you can see this one. This projection, I'm not having the dimension, so approximately I'll be making it. With respect to the central line, I'll be making this, let's say 50 mm. Then in that side, I'll be making approximately like this. I don't know the dimension, so just I'm making like this. Okay. The outlet for this one is outlet. Inlet is this, which one? Inlet is round in shape. Outlet is rectangular.
is outlet, this one. Outlet dimension you can find that is this one. Correct. This is representing the outlet. Outlet is rectangle in shape. Correct. Outlet, for example, that is this 450, 600 like that, but it will vary. It is not constant. Okay. So outlet diameter, how we can see? This is H and W. Actually, this H and W is width and height. Width and height of outlet duct that you can find from here. Width and height is square in shape only for this model. Width height is 250, width is 250. So outlet dimension is 250, 250. Okay. So just to represent that, with respect to the center line, I'm just slightly making a 2.5 or 5 mm line. Just to represent it. That's it. Okay. And I'll be 250, 250. Now I'll be offsetting this one to 125 there and 125. Actually, this is 250, 250 only. Can make a line or polyline and close. That is my outlet. So this is my VAV for these spaces. Okay. So when we are connecting the VAV inlet, different ways, there is no proper. From the duct branch, VAV inlet is what? A round in shape. So from the duct side, you can cut a collar of 100 mm. From there, you can take a flexible duct. That flexible duct you can connect here. That is one method. The next one, after the collar, sometimes when the machine is working, if it is a rigid in duct, flexible duct, that is fine. If you are using a rigid connection, after this one, no, we will be using a flexible duct connector. Same like in the machine mouth we are connecting. 100 mm, suppose if this is 100 mm, 100 mm flexible duct connector we will be providing. If we are providing, that will be good. Why? Vibrations it will isolate. Because when this, if the VAV is having a fan, VAV is not having always fan. Some fan powered VAV is there. The VAV is having a fan. Whenever it is working, it may create some vibration. So anyhow, this VAV is not having any fan and all. Fan powered VAV only you have to consider that flexible duct connector. Otherwise, you can neglect it. If the vibration is there, then only. Okay. Otherwise, what you can do, if you are having enough spaces, you can use a rectangle duct like this, shoe collar. Rectangle duct face, you can cut a collar. From that collar, you can connect to the inlet, or from here, you can take a flexible duct, then you can connect it. Anyhow, if you are going to fundamentals, see, normally in plenum also, if you are providing acoustic insulation, that is fine. In the last class, I didn't mention it. Plenum box, before connecting it, if you are providing acoustic insulation, that will be good. Correct. Anyhow, already we are considering 25 mm here and 25 mm here for acoustic insulation allowance, because that we have provided for hammering, no? So that is more than sufficient. So acoustic will be covering in it. So plenum also, when you are providing acoustic insulation, that will be good. Okay. And here you can see in the VAV, when you are considering a fan or VAV, the inlet is called upstream. Outlet is called downstream. Okay. Do not use a flexible duct immediately upstream of VAV boxes. But flexible duct they are saying, but here you can see in this image, they are suggesting flexible connectors for fan powered units. Without knowing this, everyone will be proposing flexible connector for whatever the VAV it may. No, we don't want them. Flexible duct connectors we need in the VAV with the fan only, fan powered, because if the terminal unit is having more pressure drop, sometimes the fan coil unit will not be having the enough ESP to deliver it. In that scenario only we have, because normal VAV, when the actuator only is having the moving part, it will not create that much vibration. Fan powered VAV will be creating some vibration. There only you have to propose the flexible connector. Otherwise, in our case, there is not a fan powered one. Okay. Fine. And here you can see immediately you should not use any in the downstream. They are not proposing. So rigid connection, they are proposing it. But as per 100% standard, it is not practically possible as per the site condition, because here you can see after the VAV, this is inlet of VAV, this is outlet. After the VAV, they are proposing like 1.22 meter minimum duct length. As per the site condition, we will not get that always. This is inlet. When we are considering the inlet, okay, from the machine, the inlet straight duct should be minimum 3 times diameter. The diameter is 100 mm. This distance we need minimum 300 mm. But sometimes we will not get always. We will not be having this much space always. So we will be adjusting it. Correct. Okay. So, and also when you're taking a duct, and this is a duct branch, in this duct branch, when you are proposing this one, if this distance is more than 4.5 meter, okay, this distance is more than 4.5 meter, then in the upstream, minimum 1.5 meter metal duct you should propose. If you're having space, all these things we can follow. If you're not having space, I will do that now, because we are not having space now. What I'm doing, see, I'll be taking a round collar from this rectangle. A round collar, shoe collar you can try. Round shoe collar is available in the market. Or a normal, not this one. Or a normal, which one? This is a round shoe collar only. This one you can use. That will be good. Otherwise, the collar, this one, round collar. But the pressure drop will be more in this kind of scenario. Here, since it is 45-degree inclined, smooth guidance we will be getting, right? So that's why I'll be proposing a round shoe collar. Diameter 150 mm, because the flexible duct diameter is 150. So I'll be using 150 only there. Okay. So selected. So this is my duct. Yeah, double-ended. This distance, I'm just taking 4 inches, 100 mm. What's this duct? 100 mm. So O under 50, round duct only now. 50, 50. Shoe collar I should make, as you know, up to 600 mm, the shoe collar distance will be 200. Above 150, above 600 should be 200. But minimum case we can use 100 mm. So here I will be using 100 only. O under 100 mm. I'll be offsetting this. Then from here I'll be making my 45-degree. Okay. From this point, shift at approximate distance of 300, angle 45. Here double-ender, this one, this one, this one. This is my collar. It's my shoe collar. But shoe collar has to be, this is just a shoe only. The duct piece has to be extended slightly. 4 inches minimum you should extend this distance. So O under 100 mm, I'll be extending like this. Okay, so this is my shoe piece. There I can connect my VAV. Okay. Still, if you need to extend it, you can. Still, if you need to extend it, you can, no problem. Okay, so VAV, I'm just selecting my VAVs. Here I'll be going for VAV with the plenum box connection only, because rigid connection, we are not having space here. Still, from the machine mount, after 450 mm only, we have to provide the first connection. 450, where it will come? Here. So after this, so still we are having space to move it. Okay, M ender. So I'll be moving it slightly back. So okay, I can move it still back. Now let me place my VAV there. Copy, rotate it. Okay, I'll be rotating this one. Copy with respect to the inlet. I'll be connecting. If this one is a rectangle duct, from rectangle to round, I should show a transition piece. I should show a transition piece. How it will come? For example, this is my VAV. Okay, but VAV inlet is accurate now. A rectangle, if you are connecting to the VAV, this is VAV inlet. And this is my rectangle duct. Okay. When you are connecting it, a taper session will come like this one, this one. Okay. Like that, we should highlight it. Actually, what this is, it's a transition piece. Means from rectangle to round, the shape will be changing. It's a transition duct only. From rectangle duct also, we can connect it. But you should use a transition duct there. like this. From rectangle to down, around you can use a transition as well. Okay, so I have connected my VAV. Now from VAV outlet, I should connect there. Okay, anyhow, let me size this plenum. For 107 liter per second, what should be, is 107, no? 107. What should be the flexible duct diameter? 107 liter per second, 202, let's say 200 mm flexible duct I need there. Next size is 225 only. Next size is 225, this one, discussion room 1. Next size is 225. Flexible duct I am getting, how much? 107, 200 mm flexible duct. 200 I am. So what about the plenum? How much dimension I need? I'll be connecting the flexible duct in this side, or even straight also if it is possible. No, straight. Curvy we can provide. Okay, flexible duct. Okay, like this. This side I'll be connecting the flexible. So since the flexible duct diameter is 200 now, next size is 225. So what about this width? This will be, since the neck is 225, this should be minimum 225, but this is not possible, right? Because the flexible duct diameter is 200. You need at least this one 250, 250. So that's why 225 neck is not possible. You can't connect your collar there. So I'll be making that as 300 by 300. Correct. Means 225 means if this flexible duct diameter is how much? 200, correct? Which one? 200. So 25 mm allowance here, 25 mm allowance here. So minimum this distance you need 250. But next size is how much? 225 only. 225 means if you are considering 250, just 25 mm you are getting, means 12.5 mm allowance here, 12 point. That is 2 less, no? So that's why I'll be considering that into 300. But at least like which one? Including, suppose if you are planning to provide this one, which one? Acoustic insulation within the plenum box, even that will be also covering in it. Okay, so I'll be considering 300 by 300. Height will be, since the flexible duct diameter is 200, height I need minimum 250. 250 I can use, or if you want to make 300, 300, 300 plenum, fine, no problem. We are having enough space there. Otherwise, 300, 300, which one? 300, 300, 250 is also fine there. Flexible duct diameter is 200, 25 mm top side, 25 mm bottom. So even that is also fine. No issue. Okay, I'll be using 300, 300, 300. 250 is fine, but I'm selecting that one. Copy. Okay, let me place it there. Plenum box 300, 300, 300. Flexible duct one number. Diameter of flexible duct is 200. Okay. Let me make a plenum box there. 300, 300. So 300, comma 300. Okay. And flexible duct of 200. So offset 100 here, 100 there. This distance I am taking 50 mm. Offset 50. Unwanted things we can trim now. Delete this one. That's my plenum box. Select it. And I'm just copying this with respect to this point, and I'll be placing it there. Now from the outlet, we should connect this one. Which one? Flexible duct. But as you know, the flexible duct is round in shape. VAV outlet is rectangle in shape or square in shape. 250, 250 is the outlet here, correct? For VAV data sheet, you can find the outlet of VAV is height and width is 250, 250. So from 250, 252, 250, 252, which one? 250, 252, 200, we should change it. So we definitely from square to round, we need a transition phase. As per DW 144, we have to provide a taper there. The taper angle should be maximum 22.5 degree or less. But if you are going to Ashray fundamentals, They're recommending duct transition should not exceed and include an angle of 15 degree there. DW 144, that is duct transition means taper piece, taper session. So they're recommending like a 15 degree in it. But now if you are following DW 144, you can follow 22.5 degree. Here they are duct transition pieces, they are like representing how much less than or equal to 15 degree. Since here I have followed DW 144, the same only I'll be following there. So what I'm doing means I'll be making a rectangle duct there, because I need a piece there. Okay. And let me select. Or two ways we can connect. Two ways we can connect. First thing, from here we can take a 250 duct. Correct. Like 250 duct. From the 250 duct, here we can provide a round collar of 200. There we can connect a flexible duct. Then that flexible duct we can connect there. The pressure drop will be slightly more. Otherwise, from 250 to 200, a transition piece we can provide there. Here we can connect the flexible duct. Then we can connect it. This will be good. Correct. Since the pressure drop will be less there. So both the way you can connect is like from the rectangle duct or square duct, middle side you can propose a collar, then you can provide, but the velocity will be high there. So I'll be providing a transition piece there. So let me try with the 15 degree first. So it means 150 mm. 150 I'm trying now. So over enter. What's the diameter of a round duct? Diameter of a round is 200, right? So select this one. Over enter. 200 means 100 mm. There, 100 mm. Here. Okay. Now this one I am offsetting. Over enter 150. And check the angle. This angle should be less than 22.5 degree. 9 only. So whether that is Magna standard or if it is ASHRAE or if it is DW, fine. So the taper length you need just 150, that is fine. Okay, angle is okay, right? Fine. So just leave it there. So I'll be making that. This is my transition duct. It's from 250 to 200. Okay. 250 to 200, I'm having that. Now after this one, directly we can't connect a flexible duct there. To connect the flexible duct, we need a piece there. Correct. This is your transition duct. How we can connect the transition duct in this point? Here it is fine, but that is not the real transition piece. Like, suppose if it is coming like this. Here it is. This is okay. In this kind of transition duct, the flexible duct you can connect here. In this collar. Correct. Then you can find it. But if the connection is coming only like this and all, we will not be having place to connect the flexible duct in that scenario. When this is also fine, here you can connect the flexible duct, then you can wrap it by the help of Jubilee clip. But in this kind of arrangement and all, we are not having provision to connect it. Correct. So this collar also, this is a transition piece from the square to round. This you should show minimum 2 inches, no 50 mm. Any dimensions higher than 50 is fine. Minimum 2 inch extension also you should show there. So that I have to show. Or enter 50 mm. Okay. Now you can show me here double enter. Okay. From this point you can connect your flexible duct. That flexible duct you can connect here in this point. So delete this one. Also this distance, if you want to make it backside, correct, you can do that. Okay. I've just shown it. Okay, take my flexible. Copy with respect to this point. Okay, we can place it here now. Then this one you can connect. Make sure ortho is off when we are adjusting this one. What is okay. Fine. If you are moving here, we will not get space there. When we are placing like straight to connect the flexible duct here, now we will not be having this space there. That's why I made slightly back side. There is no other option. But if the duct is having space there, then like this, if we are able to connect, then that is fine. But here also we are not having the space there. Okay. So I did the connection. Fine. Like this only, you have to connect it. Now VAV number we have to provide that we can make at the time of scheduling. Now the duct dimension, since the flow rate is decreasing, right? From 350 to 243, the flow rate is decreasing. The duct dimension you can decrease now. You can. Not mandatory, but you can. If it is mandatory, you can do that. Sorry, if it is required, you can do that. So I will be decreasing that 243 liter per second. 243 liter per second. 0.8 Pascal per meter. Since this branch is having an external height of 350, if we don't want that much, no? Keep it there, 250, 250. Aspect ratio 1 we are getting there now. 250, 250. Fine. So SAD 243 liter per second. I'll be making that as 250, 250. Next one. So let me trim this one. And you can delete it. Okay. After making this, you have to extend this into 150 mm. Oh, enter. 150 enter. Okay. Extend it. E extender. Boundary. This one. This one. Okay. TR double enter. This one. Reference line you can delete. See, this is like a 250, 250, but you should mark that as how much acoustic insulation has to be considered here, no? Because acoustic insulation length we are having until here, until this point. So that's why if you are providing acoustic insulation, definitely in this branch also we should consider that allowance. So we should mark that as 300, 300. 300 into 300. Okay. Means 300, 300. See, I'm considering like a 50 mm, 25, 25 for which one? 25, 25, top side 25, bottom side 25, inside the duct. Fiberglass only I'm considering. But if you are going for some other material, 13 mm only is mandatory. 13 mm top side, 13 mm bottom side. No, maximum we can consider for time being. Okay. So 300 means just 50 mm reduction. No, just for 50 mm it is not mandatory actually. Actually, we can extend until here. Only 50 mm, no. Only for 50 mm it is not mandatory. But anyhow, do that anyhow. I did that now. So, enter. 300 means like 150. If you're not considering like this distance, let me try 150. Enter. 150 enter. Taper angle. Taper angle should come less than 22.5 degree. 9 degree only. Fine. Okay. Delete. Trim this one, this one, this one, this one. Okay. And delete. Fine. Now here 105 liter per second. Here also in this branch also we should provide. Here I have tried which one? I have tried a flexible connection with the plenum box. Here also you can connect flexible connection with the plenum box. No problem. But for your knowledge, what I'm doing means here I'll be going for after the VAV. Inlet of VAV might be fine. After the VAV, I will be connecting with the flexible connection, not flexible connection, rigid connection I will be trying. Rigid. Anyhow, let me size this one, 105 liter per second. VAV same only, 105, the same range only it will come. Same VAV only we have to use here as well. Okay. So VAV, I am planning to provide here. 105 liter per second. 105 liter per second. What's the duct dimension I need? 105 I need 200, 200, 200, 175, 200, 200. But you have to make sure that what's the VAV diameter? VAV inlet diameter is 100 only. So this duct face should have, suppose if you are planning to cut it from the face of duct you can take like this. Okay. Here you can provide a shoe collar. Okay. In this shoe collar, you can connect your VAV.
So since this diameter is 100 mm, this duct height should be minimum 150. Then only you can connect it. One thing. Or if you are planning to cut it from the face of duct, here we'll be proposing elbow. Okay. So this duct in the face here, the face should be, if the flexible duct or the VAV inlet diameter is 100 mm, this should be minimum 150, 150. Here 150, here 150. Then only we can connect it. But here it is already 200, 200, 175. You can round into 200. Fine. So I said 105 liter per second. That one I'll be making 200, 200. Okay. Let me make it now. TR double ender. 200 means 100 mm. O ender 100. So 100 mm there, 100 mm here I'll be making. Okay. And the distance I am taking 100 only now. Space is a problem. 150 I am not taking. O ender 100. Okay. 100 mm here. Now from this point I'll be making a 45 degrees. So shift at approximate distance of 250, angle 45. Now we can trim this one, this one, this one, and do this too. Fine. Now, here I need an elbow. Throat radius we can consider width by 2. Okay. Up to 400 mm duct dimension. The width is, here it is 200 only. Up to 400 mm, minimum throat radius should be 100. So the throat radius here you can consider 100. Above 400, two options. Medium radius or long radius. Short radius is minimum 100, but that is applicable only until 400 mm. The duct dimension above 400, you should go for medium radius. That is called width by 2 times. Throat radius should be, if it is 200 or if it is 600, 600 by 2, that is 300. Anyhow, 200 case, 200 by 2, you'll be getting 100 only. And or if it is width time can come, means the duct width is 400, you can go for 400 here. But anyhow, it is short radius, we can try 100 mm, you can try, or even if you are considering width by 2, 200 by 2, what you will get? 100 only. No? So here we are having one option, 100 mm. So let me, this one. Okay. So just you can try for fillet. Fillet, okay, radius. Fillet radius, I'll be considering 100 mm, ender, here and here. Okay. TR double ender, I am trimming this one. And after that, you have to offset this into width times. Width of duct is how much? 200 only. No? So O ender, width of duct is 200 ender. Okay. Offset this one. Now you can trim this one. Okay. This one you can delete. And you can close it. Okay. Fine. So that's. Now, elbow is ready until there. Now, after the elbow, I need to provide a transition. Correct. Means from now I have to provide my, but this much distance I am having now. So still I can move my duct backside. If I am moving the duct backside, the problem, what's the problem? No. See, actually, we are having a acoustic insulation until this point only. Until this point. But the action, so we will be providing acoustic insulation until here only. Duct outer dimension remains 300. After providing acoustic insulation, we will get 250, 250. But what is our requirement? 250, 250 only. So you can consider after this point, okay, if you are maintaining the same 300, 300, internal dimension also you will get 300, 300 there. So in that scenario, what will happen? Air velocity will decrease in this session. But since it is a very limited session, it's not a big issue. But if this one, again, if we are moving backside, that region will increase. So more velocity reduction will happen in that area. Understood? Since we are providing acoustic insulation until this point, even if the requirement or required dimension we need inside is 250, that much only we are getting it, because even if the duct is 300, after providing acoustic insulation inside, the clear 250 we are getting. But we will stop the acoustic insulation until this point. But the problem, after this point, even if our requirement is 250, but duct internal dimension remain 300. So what you have to do? Either you can keep your duct here, or acoustic insulation you have to extend until that point. Means if you are planning to move this here, if you are planning to move this until this point, you have to extend your acoustic insulation to maintain the same velocity. Otherwise, velocity within the duct, even if we are not taking the takeoff, any branches without taking that, the duct velocity will be decreasing in it. So no issue, I'm not moving it, rather I'll be extending this duct up. Okay, I'll be extending it. Okay, let me approximately, I'm not having any length there. Approximately, I'll be extending until this point. Okay, this point. Fine. Now, after this point, definitely I need the taper, right? So TR double enter. Now it is rectangle, square in shape, 200. Now from 200 to 100 mm, correct? I need to taper it, right? Same like this. But this was different, 200 flexible. Here, VAV inlet is how much? VAV inlet 100 mm only. So I have to do that. So O enter, offset distance is 100 means 50 enter. 50 mm here, 50 mm here. Okay. So this distance, initially we can try 150, then 300 until we are getting the angle. O enter. First I am trying 150 and check the taper angle here. This angle should be less than 22.5 degree. If you are not getting, means you have to 19 degree only now. That is fine. So 150 is okay. We can go up to 22.5. So the same we can try here as well. Trim this one, or even controls. Okay. Okay. Now this I'm deleting. Now after the taper, I'll be extending this window same like this. How much I have extended? 2 inches, no? The same 2 inches minimum. But here we are having a lot of space. Even if you are extending that into 4 inches, let me extend it. O enter, 100 mm, enter. No issue, we are not having a lot of spaces. Now we can place our VAV there. Okay. So let me select the VAV, mirror that one. Select it, move it. With respect to VAV, thermostat has to be provided in each space. We can provide that. I'll be placing my VAV there. Now after the VAV, I have to connect which one? Duct. Rigid connection. I'm not using flexible there. Flexible, if you are using, that is good. But how to, we can try for, in real scenario, everywhere you can go for flexible connection, no problem. But just for class. Same like in last session, even if it is possible to provide rigid connection, you can try. But just for explanation, I have covered this flexible and plenum. The same way, here I'll be going for rigid now. Anyhow, if you want to provide the rigid connection, the flow is very limited there. How much it is? Since the next size is 225, duct width we need minimum 275. Then only we can try the rigid connection. Correct. So 105 liter per second. Okay. Since the plenum or the diffuser next size is 225, if we need to make the rigid connection, the duct width should be 50 mm higher than 225. How much it is? 275. But 275 is a non-dimension, multiple of 25. You have to round that into multiple of 50. So we need minimum width 300. Other dimension I'll be getting 125. 125, what we can do? 125 you can round into 150. 150. That's why after the VAV, I'm trying rigid only. So I have to resize that one. After the VAV. Before the VAV, it was different. Now after the VAV, different size. 105, that is 300, 150, 125 only, but I am rounding that in one. Okay. Now, the duct dimension will increase there. Select it. Okay. And 300 means 150. So O enter, 150 enter, 150 in this side, 150 there. Okay. Now from next size, you know, right? How much? Our next size is 250 only. So 250 to 300, we need a taper there. Taper angle, first we can try for 150 taper length. So O enter, 150. The taper angle should be taper angle. This angle should be less than 22.5. Here we are having just a 9 degree. So even that is fine. Okay. Yeah, double enter. This one, this one, this one. Okay. Clear? This is a way the rigid connection we are trying. Understood? If you're having VAV, you don't want to propose VCD in the duct branches, but here everywhere we have to propose it, VCD. We can give that. Clear? Okay. Now I need rigid connection 225 neck only. So I am selecting 225, 225. Next size is 225. Let me make a cross mark there. Here as well. So this will be representing the drop. Now after making your rigid connection, you have to extend this into minimum 150 mm. 150 under 6 inches. You can extend up to 12 inches. TR double enter this one, this one, this one, this one. Okay. Now all this till you can. So that's our VAV connection. Fine.